Welcome to Relaxing Subjects. Settle in. Let your shoulders drop a little, the way they do when you finally stop holding the day. You don't need to follow anything closely tonight. You don't need to remember a single name or number. If your mind drifts, let it drift. If your eyes are already heavy, let them close. The words will keep coming, soft and slow, and they will be here whether you stay awake for them or not. There is nothing to figure out here. Nowhere else to be. Just a quiet voice and a strange and beautiful thing that happened inside a laboratory that we are going to walk through together, gently, one piece at a time. So let me tell you about a moment in a quiet room years ago when a group of scientists looked at the readings coming off the head of a man sitting very still and could not quite believe what they were seeing. The man was a monk. He had wires resting against his scalp, hundreds of tiny sensors, the kind that listen to the faint electrical weather of the brain. He was not moving. He was not speaking. To anyone watching through the glass, he would have looked like the very picture of rest. Eyes soft, breath slow. The stillness you might imagine when you hear the word meditation. And yet the machines, the ones that translate the brain's whispering into lines on a screen, were not drawing the calm, flat lines you would expect from a resting man. They were drawing something the scientists had never seen before. Not in this kind of healthy, ordinary human brain. Not in all the years of records they could find. Let me say that again, slowly, because it is the strange seed of everything we are going to talk about tonight. When they searched the scientific literature, all the careful measurements gathered over decades of studying brains at rest, at work, asleep, awake, frightened, focused, they could not find a single prior report of what they were watching come off this monk. The pattern was, in their own careful words, never before reported in a healthy human being. And here is the part that turns the whole story on its head. The part you can let sink in as you lie there. The reason this matters, the reason it overturns almost everything we have been told about what meditation is. That pattern was not calm. It was not sedation. It was not the brain going quiet, dimming its lights, drifting towards sleep. It was the opposite. It was the brain lighting up with a kind of high, fast, coordinated activity, an intensity, a power that the resting beginners next door simply did not show. The monk looked from the outside like the very image of peace, but inside his brain was doing something that looked far more like an athlete in full motion than a man taking a nap. Now I know what we have all been told. We have all heard the story so many times it feels like simple common sense. Meditation calms you down. Meditation is about relaxing, about emptying the mind, about lowering your stress until you melt into the cushion. The wellness world has sold it to us as a kind of soft off switch for the nervous system. Breathe in, breathe out, and slowly power down. And there is some truth in that, of course, but it is at best half the story. And in the most striking findings we are going to sit with tonight, it is closer to half wrong. Because what the lab kept finding again and again was not a brain being switched off. It was a brain being trained on, built up, tuned the way you might tune a muscle or an instrument or a long-practiced skill. The picture that came out of these rooms is not meditation as a sedative. It is meditation as something much more like exercise, athletic training for the circuits of the heart. And the remarkable thing, the thing that makes this worth a whole quiet night, is that for the first time the lab could actually watch the muscle grow. So let me hold that promise out to you gently, like a lamp at the start of a long walk. Tonight, we are going to follow that thread. We are going to find out who these monks were and what they had done to their brains to make the machines stop and stare. We are going to learn what that strange, never-before-seen pattern actually is, and why it is the signature of effort and not of ease. And later, much later, when you are likely already drifting, we are going to discover something even stranger, that there is a difference deep in the brain between feeling sorry for someone and truly wishing them well, and that one of those two things can quietly wear you down while the other one builds you up. But that is for later. For now, let us simply meet the monks. Let me set the room for you. The work happened at a place called the Center for Healthy Minds at the University of Wisconsin-Madison. The man behind much of it is a neuroscientist named Richard J. Davidson, who had spent his career studying emotion in the brain and who had become, quietly and seriously, interested in a question most of his colleagues would have considered a little soft, a little fringe. What does a lifetime of mental training actually do to the physical brain? Not a weekend retreat, not an app on your phone. A lifetime. The study that startled everyone was published in the year 2004. It appeared in a journal called PNAS, the Proceedings of the National Academy of Sciences, which is about as respectable a home as a finding can have. The lead author was a researcher named Antoine Lutz, and alongside him on that paper were Greichard, Rawlings, a monk named Matthieu Ricard, whom we will come back to, and Davidson himself. Keep those names if you like, or let them go. The names matter less than the people, and the people in this case were extraordinary, because the scientists had done something clever. If you want to understand the limits of what the human body can do, you do not study someone who jogs on weekends. You study an Olympic athlete, someone who has spent 10,000, 20,000, 50,000 hours pushing one specific skill to the edge of what is possible. You study the extreme so that you can see clearly and without doubt what the system is capable of when it has been trained to its absolute limit. And that is exactly how Davidson came to think of his subjects. He called them, in effect, the Olympic athletes of the mind, the Olympic monks, because that is what they were. They were not casual practitioners. They were 8 long-term Tibetan Buddhist monks, men who had given their lives over to the training of the mind and the training of the heart in the way their tradition had refined over many centuries. Let me give you the numbers slowly, because the numbers are the whole reason this works. These 8 monks had each accumulated somewhere between 10,000 and 50,000 hours of meditation practice. Sit with that for a moment. 10,000 hours at the very low end, 50,000 at the high, and they had not done it in a hurry. They had built those hours up over the span of 15 to 40 years, decades. A practice woven into the fabric of an entire adult life, day after day after day. In the quiet, in the cold, on the cushion, returning to the same inner work, the way a pianist returns to the keys. Think of what that means in the language of any other skill. You have heard, perhaps, the rough rule that 10,000 hours of dedicated practice is what it takes to reach mastery of almost anything. An instrument, a sport, a craft. These monks were not at the start of that road. They were not at 10,000 hours and stopping. Some of them were at 30, 40, 50,000 hours. They had spent more time training their attention and their compassion than a concert violinist spends with the violin, more than a surgeon spends with the scalpel, more than almost anyone alive spends doing any one deliberate thing. If mastery is real, if a human being can become a true virtuoso of the inner life, then these were the virtuosos, and nobody had ever put a virtuoso of meditation under the machines before. Now, a finding is only as good as what you compare it against. A single, remarkable brain proves nothing on its own, so the scientists also gathered a comparison group, what we call controls, 10 healthy student volunteers, ordinary young people, the kind you might pass on any campus, with no special history of meditation at all. And the researchers did not simply leave them untrained, they taught them the practice. They gave the students 1 week of instruction in the same kind of meditation the monks would be doing, so that everyone in the room knew, in principle, what they were being asked to do. So picture the experiment now gently, the way you might picture a scene in a story before you fall asleep. On one side, 8 men with up to 50,000 hours and 40 years behind them. On the other, 10 kind young volunteers with 7 days of practice. The same instruction, the same machine, the same quiet room. And then, simply, the question. When each of them turns their mind toward compassion, toward boundless goodwill for all living things, what does the brain actually do? The first surprise came before the meditation even began. This is one of those details that is easy to skim past, and I want us to slow right down for it because it tells you something profound. Before the monks were asked to start, while they were simply sitting there at rest, at their ordinary everyday baseline, the machines were already reading something unusual. The kind of fast, high-frequency brain activity that the scientists were interested in, we will give it a name in just a moment, was already elevated in the monks, already higher than the students, already at rest, lit up in a way the beginners were not. Let that land softly. The decades of training had not just given the monks a button they could press to produce a special state for the length of an experiment. The training had changed their resting brain, their baseline, their default. Whatever they had been doing, all those thousands of hours, had not just rented them a temporary mood. It had, it seemed, rebuilt the ordinary, everyday texture of their minds. The elevated state was not something they had to reach for. To some degree, it had become simply who they were. Hold on to that quietly because it is a door we will walk all the way through later. This difference between a passing mood and a lasting change in the very fabric of the mind. The scientists have words for it. A state, they would say, is the weather. A trait is the climate. And what they were beginning to suspect, even in those first readings, was that they were looking at climate, at weather that had repeated itself so many thousands of times it had reshaped the whole landscape. But let us stay with the meditation itself. The monks were asked to enter a state of, in the language of the tradition, unconditional loving kindness and compassion. Not compassion for one person, not warmth toward a single beloved face, a vast, objectless, boundless readiness to wish all beings well, all beings everywhere, with no limit and no exception. A pure state of care, generated and sustained from the inside without any particular object to lean on. And as they did this, as they generated that boundless compassion, the machines drew their impossible lines. The high, fast activity that had already been elevated at rest now surged. It climbed to amplitudes, to strengths, to sizes, that, as we said, had never before been reported in a healthy human brain. The students, doing their honest best after a week of practice, showed a modest, ordinary response. The monks showed something that made the scientists go back and check their equipment. So let me finally give the thing its name, the way you might finally name a star you have been pointing at in the dark. The activity they were measuring is called gamma waves, gamma band oscillations, if you want the full and proper phrase, but let us just say gamma. It refers to a particular speed of electrical rhythm in the brain. Here is the gentlest way I can offer you what that means. The brain is, in a sense, electrical. Billions of cells chattering to one another in tiny pulses. And when many of them pulse together, rising and falling in unison, it makes a rhythm, the way a crowd clapping together makes a beat, where individual hands would make only noise. Scientists can listen to those rhythms from outside the skull, and they sort them by speed. The slow, rolling rhythms belong to deep sleep, to drowsiness, to the very edge of unconsciousness, the heavy, syrupy waves you are probably sinking toward right now. The faster rhythms belong to alertness, to focus, to a mind awake and engaged, and gamma is the fastest of the common rhythms. The monk's gamma fell in a range the scientists measured at roughly 25 to 42 cycles every second, 25 to 42 times a second, this rhythm rising and falling. That is fast. That is not the slow, sleepy roll of a mind powering down. That is, if anything, the rhythm of a mind in high, clear, intense engagement. Now, do you see why the relaxation story begins to crumble? If meditation were nothing but the brain switching off, the readings should have drifted down toward those slow, drowsy rhythms, toward the syrup. Instead, in these masters, in the very people with the most practice, the most mastery, the most stillness on the outside, the brain was running its fastest, strongest rhythm at a level never recorded before. The deepest peace these men could generate was not in the brain, a quieting. It was an extraordinary coordinated firing up. But amplitude, strength, size, how big the wave is, was only half of what stunned the researchers. There was a second feature, and in some ways it is the more beautiful one, so let us breathe and turn to it slowly. The word for it is synchrony, gamma synchrony. And to feel what it means, I want you to imagine, just for a moment, a great orchestra. Imagine all the sections of an orchestra, the strings, the brass, the woodwinds, the drums, far at the back. Now imagine each section is in a different room of a very large house, far apart from one another, unable to easily hear the others. If each section simply played on its own, fast and loud, you would have power, yes, but you would have chaos, a wall of unrelated noise. Strength without meaning. But now imagine that despite the distance, despite the separate rooms, every section comes in together perfectly on the same beat. The first violin and the distant timpani rise and fall as one, the whole house, room by room, breathing the same music at the same instant. But that is not just power anymore, that is coordination. That is many separate voices bound into a single, unified thing. That is a symphony. That is synchrony. And that is what the monks' brains were doing. The fast gamma rhythm was not just strong, it was phase-locked, rising and falling in step, across regions of the brain that sit far apart from one another. Distant areas, in different neighborhoods, of the brain entirely, pulsing in unison. The whole instrument playing together. Why does that matter so much? Because scientists have long suspected that this kind of fast, synchronized, large-scale coordination is connected to some of the highest things the brain does, to what they sometimes call binding, the great mystery of how the brain takes 1,000 separate scraps of experience, a color here, a sound there, a feeling, a memory, an edge, a meaning, all processed in different places, and stitches them seamlessly into one whole, unified moment of being. The single, smooth experience of being here, now, all of a piece. Gamma synchrony is one of the leading candidates for the music that does that stitching. It is associated with high-level integration, with attention, with learning, with the binding of the brain's scattered work into one coherent, conscious experience. So when the scientists saw the monks producing this synchrony at such strength across such distances, what they were likely watching was the brain operating at an extraordinary level of integration, not scattered, not dimmed, not asleep, but gathered, unified. Many regions far apart, all playing the same note at the same instant, a brain working as a single, coordinated whole, lit up in the act of generating boundless compassion. Doesn't that turn the picture inside out? We are taught to think of the deepest meditation as a kind of beautiful emptiness, a switching off, a fading toward nothing. And here was the deepest meditation of the most practiced humans on earth showing up in the machines, not as nothing, but as everything firing together. As the most coordinated, most integrated, fastest singing the brain seems able to do. The stillness on the outside was the calm surface of a sea that was underneath, fully and powerfully alive. I want to be honest and careful with you here, the way good scientists are careful, because the honesty is part of what makes this trustworthy enough to fall asleep to. The popular press, when it got hold of these findings, ran a little wild. There were headlines about a monk whose brain lit up like a Christmas tree. There were even bolder claims that we will come to and gently set straight on another night. The scientists themselves were far more measured. What they reported was a difference, a real, striking, measured difference, between people with tens of thousands of hours of training and people with 1 week of it. They did not claim it was magic, they claimed it was training, and that somehow is the more astonishing claim of the two, because if it is training, if this never-before-seen brain state is something the monks built hour by hour, year by year, then it raises the question that I want to leave hanging over you tonight, like a small, warm light you can drift off beneath. The monks took 30, 40 years, 50,000 hours, that is a whole life. And so the natural, slightly defeated thought is, well, that is wonderful for them, but it has nothing to do with me. I will never sit on a cushion for 50,000 hours. My brain will never sing like that. And here is the loop I want to open and leave open, the question we will answer much later when you are softer and heavier and closer to sleep. How long does it actually take to begin? How many hours, how many weeks before the ordinary human brain, a brain like yours, lying here right now in the dark, begins to physically change under the gentle pressure of this kind of practice? You might assume the answer is decades. You might assume it is forever out of reach. But the number the laboratories have found is far, far smaller than you would ever guess. And we will get to it, I promise. Just not yet. For now, let us stay a little longer with the wonder of what they found, and let us turn it over slowly, the way you turn a smooth stone in your hand at the edge of sleep. 8 men, 10,000 to 50,000 hours, 15 to 40 years, a baseline already lit, a rhythm called gamma, fast and strong, 25 to 42 cycles a second. And that rhythm not scattered, but synchronized, phase-locked across distant regions, the whole brain singing in one bound chord, while the man at the center of it sat perfectly, peacefully still, generating nothing but a boundless wish for the well-being of all living things. Think about what that means about the wish itself. We tend to imagine compassion as something passive, something soft and faint, a gentle feeling that washes over us when we happen to see suffering and then fades, something that just arrives or doesn't. But that is not what the machines were describing. The machines were describing compassion as an act, as something generated, sustained, produced by the brain, working hard and working together. Not a faint feeling that happens to you, but a powerful state that you make. And if compassion can be made deliberately by the mind, if it is a thing the brain does rather than merely a thing the brain feels, then it can be practiced. And if it can be practiced, then it can be strengthened like a muscle, like a skill, like any other capacity a human being trains across the hours of a life. That single idea that the warmth of the heart is not a fixed quantity you are simply born with more or less of, but a trainable capacity, a muscle of care that grows with use, that is the quiet revolution sitting underneath all of this. It is the thread that runs from a Tibetan monastery where this training was refined across many centuries, all the way into a Wisconsin laboratory with its wires and its screens. And the most moving thing about the 2004 study is simply this: for the first time, the two halves of that thread were able to look at each other, the ancient practice and the modern measurement, the cushion and the EEG, and they recognized each other. The monks said, "We are training the heart." The machine said, "Yes, we can see it. We can see something happening in there that we have never seen before." And it is not you switching off, it is you switching on. So let us hold that gently as we go on. The first and most important thing to release tonight is the old, tired idea that meditation is just relaxation, just a softer, slower way of going limp. The masters of the practice showed us something far more interesting. They showed us a brain in full, coordinated, high-frequency song. They showed us that the deepest peace and the highest activity are not opposites at all, but can live together at once in the same still body. They showed us that compassion, far from being a faint and passive feeling, can be one of the most active and integrated things a human brain ever does. And they left us with a question, didn't they? The question that will carry us forward into everything still to come. If the brain is something you can train like this, if the heart is a muscle, and the lab can watch it grow, then what exactly is the muscle? Where is it? What does it look like when it changes? Because a rhythm on a screen is one thing, but the scientists wanted more than a rhythm. They wanted to know whether the very flesh of the brain, its physical shape and substance, could be remade by the practice. Whether the structure itself could be sculpted the way a body is sculpted by years in the gym. Whether you could take a brain and through nothing but the quiet repetition of attention and care, actually change what it is made of. And to begin to answer that, they had to leave the monastery behind for a moment. They had to look at something much smaller, much closer to home. They had to look at a London taxi driver, of all people, and at the curious hidden organ of memory buried deep in the center of the head. And at what years of one simple, demanding habit had quietly done to it. But that, dear listener, is where we will begin again in a little while. For now, just rest. Let the monks sit in their quiet room. Let the gamma sing far away in a story you do not need to hold on to. There is nothing here to remember and nothing here to do. The brain that is listening to me now, growing heavy, beginning to slow, that brain too is changing gently, the way all brains change with everything they meet. And there is no hurry at all about where it goes next. There was a man in London sometime in the 1990s who drove his black cab through the city's streets for 12 years before anyone thought to look inside his head. His name was not important to the study. What mattered was what he had spent 12 years doing, which was memorizing, turn by turn and landmark by landmark, the entirety of London's street network. A thing so complicated that it has its own name and its own mythology among the people who do it. They call it the knowledge. And the knowledge is precisely that, not a map you consult, but a map that becomes you. Hundreds of routes, tens of thousands of named streets, every church and theatre and park and hidden square, held not on paper but in flesh, carried not in a phone but in the very tissue of the brain. When the neuroscientist Eleanor Maguire and her colleagues at University College London put 16 of these drivers into a brain scanner around the year 2000, they found something that, at the time, surprised almost everyone who heard it. The posterior hippocampus, a small, seahorse-shaped region buried deep in the center of the brain, the one we now associate with spatial memory and navigation, was measurably larger in the cab drivers than in 16 age-matched controls who had not driven cabs. And more than that, the more years a driver had spent on the road, the more pronounced the difference. Time spent in the practice had literally enlarged the relevant part of the brain. The organ had grown to meet the demand. It sounds almost too simple, but it was, in that moment, a quiet revolution. Because what it said, or what it demonstrated with scanners and measurements and published numbers, was that the brain is not a fixed thing. It is not handed to you at birth, fully formed, set like concrete. It is more like a living landscape, shifting in response to what you ask of it, thickening where you use it, thinning perhaps where you do not. The maps you carry in your mind leave marks in the matter of your mind. Scientists had a name for this principle, though they were only beginning to understand its full reach. They called it neuroplasticity. And though the word sounds technical, the idea beneath it is old. The old saying goes that neurons that fire together wire together, a shorthand for the Hebbian principle named for the psychologist Donald Hebb, who proposed in 1949 that when two brain cells activate repeatedly at the same time, the connection between them strengthens. Repetition builds pathways, habit carves channels. What you practice, you become, not metaphorically but literally, in the physical structure of the tissue. The taxi drivers were proof of this at a very concrete, very human scale. And when Richard Davidson and the team at the Center for Healthy Minds in Wisconsin began to think seriously about what was happening in those monks, those 8 long-term Tibetan Buddhist practitioners sitting in the scanner with their gamma waves singing at amplitudes no healthy human had been recorded producing before. The taxi driver was exactly the kind of evidence they needed, because if a man driving the same streets year after year could physically remodel the part of his brain that handles space, then what might a person do who had spent between 10,000 and 50,000 hours remodeling the part of the brain that handles care? The question, when you hold it that way, is not mystical at all. It is almost athletic. It is the same question a coach asks when a sprinter comes in having trained since childhood. What exactly has the training changed? Not in their mindset, in their body, in their muscles and tendons and the firing patterns of their nerves. The mind, Davidson kept saying, is a biological process, and biological processes can be trained. The brain is shaped by experience. So if compassion is a practice you return to hour after hour, decade after decade, what does it do to the brain that holds it? Take a slow breath here. Let the image settle. A taxi driver's hippocampus, slowly growing. A monk's gamma waves, already elevated before the session even begins. The brain thickening where it is asked to work. When you are ready, we will go a little deeper. The first thing the scientists wanted to know, once the gamma findings had been published and the conversation had moved forward, was whether the changes they were seeing were states or traits. This is one of the most important distinctions in the whole field, and it is worth sitting with for a moment because it answers one of the most natural objections a skeptical person might raise. A state is a temporary condition. Your mood right now is a state. Your blood pressure after a cup of coffee is a state. If a monk's brain looks different only while the monk is meditating, that is interesting. It tells you the practice has an effect. But it also means the effect disappears the moment the practice stops, like a wave that builds and then flattens, like a runner's elevated heart rate, which returns to baseline the moment they stop running. A state can be useful, but it is not the same as change. A trait is something deeper. A trait is a stable shift in the underlying system, a change in the baseline, the ground state, the way the territory is arranged when nothing special is happening. The taxi driver's enlarged hippocampus is a trait change. It is not just present while he is navigating. It is there while he is sleeping, while he is eating breakfast, while he is talking to his children. The practice changed the structure, and the structure remains changed. The scientists, led by Gaëlle Desbordes and her colleagues, published a study in 2012 in the journal Frontiers in Human Neuroscience that was specifically designed to look for this kind of lasting structural change. Not in the monks with their 50,000 hours, but in ordinary people who had completed an 8-week meditation training program. The researchers scanned participants' brains and measured their amygdalae, those almond-shaped clusters deep in the brain that function as the body's threat detection hub, scanning the environment for danger, triggering the cascade of alertness and alarm that we call the stress response. Then they showed these participants emotionally evocative images. Images of suffering, images of threat, images of the kind of thing that naturally disturbs a human being. Here is the part that mattered. They showed these images not during meditation. They showed them when the participants were in what the researchers called a non-meditative state. Just sitting there, just being themselves. And what they found was that in the participants who had completed the compassion meditation training, the amygdala responded differently, more quietly, less reactively than it did in the control group. The training had not just changed what happened during the session, it had changed the baseline. The amygdala, in other words, was quieter in its ordinary life, not because the practitioner was suppressing it, not because they were concentrating on something else, but because the training appeared to have genuinely remodeled its thresholds. The alarm, when it sounded softer. Not because the danger was denied, but because the system that registers danger had been recalibrated, the way a thermostat is recalibrated when you change its setting, not in the moment of cold, but before the cold ever arrives. This is what trait change means. And it is one of the most significant findings in the entire field because it answers the skeptic's objection. This is not just something that happens when you sit on a cushion with your eyes closed. This is something that has been carried into the rest of your life, into your ordinary Tuesday afternoon, into your ordinary reaction to an ordinary frustration. The practice, repeated enough, becomes the person. And then there was the question of structure. Not function, not activity patterns and firing rates, but the actual physical matter of the brain. It's grey matter, which is a term for the cell bodies of neurons, the working tissue of thought and feeling and memory. Could that change too? Could the tissue itself become different, the way a muscle becomes different, visibly, measurably, after years of use? Sarah Lazar at Harvard answered part of this question in 2005 in a study published in Neuroscience. She and her colleagues recruited a group of experienced meditators, people who practiced insight meditation, a form related to but distinct from loving kindness, with an average of 9 years of experience and roughly 6 hours of practice per week, and compared their brains to those of non-meditators of similar age. What they found in the images was that the meditators had thicker cortex in 2 specific regions. One was the prefrontal cortex, the region toward the front of the brain associated with attention, planning, and what you might loosely call executive wisdom, the ability to step back from immediate impulse and consider what to do. The other was the right anterior insula. The insula is a region worth pausing on because it will come up again. It is tucked inside the brain, not visible from the surface, folded inward between the outer cortex and the deeper structures beneath. And its function is something that neuroscientists call interoception, a word that means essentially sensing the interior. The insula is the brain's map of the body's own state. It monitors heart rate, breath, gut feelings, temperature, pain, the vague sense of physical ease or unease that underlies so much of what we call emotion. It is how you know your heart is racing. It is how you feel the tightening of anxiety before you have named the thought that caused it. It is the organ of felt experience. And in Lazar's meditators, the right anterior insula was thicker. The tissue was, quite literally, more substantial, more cortex, more real estate dedicated to the felt interior of the body. There was one more detail in Lazar's data that she highlighted, and it is the kind of finding that makes you stop and read the sentence again. In most people, the cortex thins as we age. This is normal. It is part of what aging means for the brain. A gradual, very slow erosion of the thickness of the outer layer, taking with it some of the function that depended on it. In the older meditators in Lazar's sample, this thinning appeared to be offset. The experienced practitioners in their 40s and 50s had cortical thickness comparable to non-meditators in their 20s. As if the practice had been, in some very modest way, a kind of maintenance, not stopping time, nothing so dramatic as that, but perhaps slowing, in this specific tissue, the ordinary drift of years. Take another breath here if you like. Let the body sink a little. The room around you quiet. The images settling in slowly, the way sediment settles in still water. You do not need to hold any of these numbers. They are just here, passing through like the breath. And then there was the study that brought all of this down to the scale of ordinary life. Not monks with 50,000 hours, not experienced practitioners with 9 years behind them, just people who had not meditated before, who came in from their regular lives, who agreed to spend 8 weeks learning a practice and see what happened. Britta Hölzel and her colleagues at Massachusetts General Hospital, affiliated with Harvard, published their findings in 2011 in the journal Psychiatry Research, Neuroimaging. The program they studied was MBSR, which stands for Mindfulness-Based Stress Reduction, an 8-week course developed by Jon Kabat-Zinn that has become one of the most studied interventions in the behavioral medicine literature. Hölzel's team took 16 participants who had never meditated, scanned their brains before the program began, ran them through the 8 weeks of instruction and practice, and then scanned them again. What they found when they compared the before and after was measurable structural change in grey matter density. In the hippocampus, that same seahorse-shaped region that had enlarged in Maguire's London cab drivers, now associated not just with spatial memory but with learning and emotional regulation. Grey matter density had increased. The participants had more of the working tissue of memory and learning in that region after 8 weeks than they had before. And in the amygdala, the threat detector, the alarm, grey matter density had decreased, less tissue there in the region associated with reactive fear and stress. And importantly, this decrease in amygdala grey matter correlated with the participants' own self-reported reduction in stress. The less their amygdala had changed, the more stress they still felt. The more it had changed, the quieter that tissue had become, the more they reported feeling genuinely calmer, not just during practice, but in their lives. 8 weeks. Not a lifetime of monasticism. Not the extreme training of the Olympic monks. Just 8 weeks of ordinary people learning to pay attention in a particular way, and the physical structure of their brains had shifted in measurable, consistent, meaningful directions. When you hear "rewired in 8 weeks," as the headlines often put it, this is what is actually being described. Not magic, not transformation, but a real, small, measurable change in the density of tissue in regions that matter for how we respond to the world. The effect sizes are modest. Scientists are careful to say so. The field has had its share of small studies, and replication is always the test that counts. But the direction of the findings across Lazar's work and Hölzel's work in the Desboard trait change study points again and again in the same direction. Training changes the brain, and it changes it in places that are not arbitrary. Now, there is a question sitting quietly at the edge of all of this, and it is the question that the insula brings into focus. Because you might be wondering, quite reasonably, what thicker insular tissue, this better map of the body's interior, has to do with compassion, with caring for others, with the wish that another person be free from suffering. It sounds at first like two unconnected things, but they are not. And the connection is one of the most elegant things the neuroscience of contemplative practice has uncovered. The insula, remember, is the organ of felt experience. It is how you know what is happening inside you. And here is the thing. The way we understand what is happening inside other people, the way we reach across the gap between self and other and feel something of what they feel, runs in large part through this same circuit. The brain uses its model of your own body to simulate the body of the person in front of you. Your insula lights up in a muted way when you watch someone in pain. The brain rehearses the pain you are witnessing by generating a small version of it in the map of yourself. This is part of what empathy is neurologically, not a mysterious leap across the void, but a kind of internal resonance, a tuning fork that vibrates when it hears its own frequency in someone else. And if the insula is thicker, more developed, more sensitive, a finer instrument, then this resonance has more to work with. The capacity to feel what you feel is the substrate of the capacity to feel what someone else feels. Interoception and empathy are not separate systems reaching in different directions. They share roots, which is why Davidson's lab and others kept coming back to a deeper question, not just whether the brain could be changed by practice, but what kind of practice changes it in what kind of way, because not all of these practices are the same. Mindfulness of breath is not the same as loving-kindness meditation. Compassion, in the specific technical sense the Buddhists mean by karuna, is not the same as the ordinary empathy we feel when we see someone struggling. And this distinction, which sounds at first like a philosophical nicety, turns out to be, in the scanner, a deeply important fact. You may have felt it yourself, though you may not have had the words for it. You may have sat with someone in pain, a friend going through grief, a family member in the hospital, a stranger in a newspaper photograph, a face on a screen, and felt yourself filling up with their suffering. Felt it land in you and press against you from the inside. Felt the sadness, the helplessness, the heaviness of it. Felt, perhaps after a while, the need to look away, or the exhaustion of carrying something you could not put down. That feeling is real, and it is not bad. Empathy, the capacity to feel what another feels, is among the most remarkable things a human being can do. But the scientists were beginning to discover that in the brain, this feeling of sharing another person's pain has a cost. And they were beginning to discover that there is another circuit, a different one, running on different tracks, that leads somewhere else entirely. This is the discovery we will reach next, the one that changes the picture most. But for now, rest here. Let the insula do its quiet work, mapping the rise and fall of the chest, the warmth of whatever surface holds you. The brain, thicker in some places than it was before, the amygdala a little quieter, the hippocampus perhaps a little richer in its grey matter, a little more capable of holding what it learns. These are not promises, they are possibilities. Things the practice points toward, the way a path points toward a clearing you have not yet reached. The clearing is a little further on, but here, in this moment, there is nowhere to go. The body knows how to breathe. Let it. The brain knows how to rest. It has been doing it in small ways all along. What the body knows how to do even now is far more than the mind tends to give it credit for. The insula knows without being asked where the breath is thickest, where the hands are warm, where the jaw is holding something it could release. This knowing, this ordinary, unremarkable, constant process of the body sensing itself, is the same knowing that Lazare found thickened by practice. The same sensing that becomes, with cultivation, a finer instrument. Not a different thing. The same thing more fully developed. And what is true of the breath is true of care. The capacity is there already in the tissue. The practice simply asks it to grow. There is a phrase that appears in various forms in the neuroscience literature around this research, and it is a phrase that Davidson himself has used in talks and interviews. He says that the brain is the organ that is most shaped by experience. Every other organ, the heart, the lungs, the liver, does its job largely independent of what you ask of it. The brain is different. The brain is, in some deep sense, made of its experience. What you repeatedly do, think, and feel becomes, over time, what the brain is. This is the principle that the taxi drivers illustrated. This is what the monk's gamma waves suggested. This is what Lazar's cortical thickness measurements showed, and what Hölzel's 8-week program demonstrated at ordinary human scale. Not that the brain is endlessly malleable, not that it changes overnight, not that there are no limits. The scientists are clear about all of this, and careful, but that the trajectory of change is real and it runs in the direction of what you practice. The monks in Davidson's original study had between 10,000 and 50,000 hours of training behind them. The students in Hölzel's study had 8 weeks. Both groups showed change. The difference was in the scale and depth of it, which is exactly what you would expect if you were looking at a skill being developed over time. The same kind of curve you see in any trained capacity, from music to surgery to the navigation of London's streets. And this is the frame that Davidson kept returning to, the Olympic athlete frame. He said, in essence, we do not expect a person who walks around the block once a week to develop the cardiovascular capacity of an Olympic runner. We do not call it a failure of running if the person doesn't transform. We understand that the training level determines the outcome, and we should understand the same thing about mental training. The monks are not mysterious. They are extreme trainees. What they show us is what the far end of the distribution looks like, and the direction the distribution runs. The direction, it turned out, ran somewhere quite specific, somewhere the scientists had not fully expected, because when they began to look more carefully at what the monks were actually training, when they began to distinguish between the different kinds of meditation practice and ask what each one did to the brain, they found a dissociation so clear, so striking, that it reordered the whole conversation. Not all care is the same in the brain, and the difference between the kinds that look similar from the outside is the difference between a system that burns out and a system that sustains. The difference in the matter of the brain between pain and reward. But to understand that fully, you need to understand what the researchers saw when they tried to produce empathy in the scanner. What happened when they asked people to simply feel what someone else was feeling, to open themselves to another person's suffering and stay there. What they found was not what the wellness world, with its calls for more empathy, more sensitivity, more feeling, might have predicted. They found a brain lit up in the same regions as physical pain, and they found in people who did this repeatedly and without the counterweight of something else, something that looked in the data very much like depletion, like a system giving more than it could replace. The next question, the one the scientists were already asking by the time Britta Hölzel's 8-week results were published, was whether there was another way, whether you could train the care and keep the care without paying the full cost of the pain, whether the ancient practice of karuna, compassion in the specific sense of the Buddhist tradition, the warm, clear wish that another being be free from suffering, was doing something neurologically different from what happened when a person simply sat with grief and let it press against them. The answer, when it came, was yes. And it came with the names of brain regions and the coordinates of circuits that the meditating mind had apparently learned to use differently. Regions associated not with pain, but with warmth. Not with aversion, but with approach. Not with the burning down of a candle, but with the steady, renewable warmth of something that feeds itself. We will reach that finding next. It is the one that changes the most. It is the one that the Tibetan teachers, sitting in their monasteries with their traditional psychology of mind, would perhaps have said they already knew, in the way that all genuine discoveries eventually feel once they are confirmed, less like news than like recognition. For now, though, let the body rest. Let the images settle. The hippocampus, quietly growing. The amygdala, its thresholds gentled. The insula, a little thicker, a little more finely tuned to the interior landscape of the self, and through that, to the landscape of every other self it encounters. The brain is not finished, it is never quite finished. And neither, as it turns out, is the capacity for care. Rest here a moment. There is no hurry toward the next thing. The next thing will come when it comes, and what it brings is worth waiting for. But waiting tonight looks like letting go, like breathing out slowly and trusting that the breath will return. It always does. There is a word in English that most people use without noticing how much weight it carries. The word is empathy. We say it as if it were a virtue, as if feeling what another person feels were obviously and straightforwardly good. The right response, the moral response, the response we should cultivate in ourselves and teach to our children. We have built it into the language of therapy and education and leadership. We speak of empathy deficits as if they were a disease. We speak of empathy training as if it were the cure. The neuroscience has something uncomfortable to say about this, and the people who found it were not trying to be contrarian. They were simply looking at what the brain actually does when a person tries to feel another's pain, and what it does instead when a person trains in compassion. What they found was a dissociation. Two different circuits, two different experiences, two different outcomes, and the difference between them is not small. Let us settle into this slowly because it is the finding that changes the most. It is the one worth taking your time with tonight. Tanya Singer is a neuroscientist, a social neuroscientist specifically, which means she studies what happens in the brain when human beings encounter one another. When they read each other, feel with each other, hurt each other, help each other. She has spent years trying to understand the neural architecture of what we loosely call caring. And one of the core questions her work has circled is this one. When we feel with someone who is suffering, what exactly is happening in the brain? And is that the same thing as wanting to help them? She suspected the answer to the second question might be no, and with her colleague Olga Klimecki and a team of researchers, she designed a way to test it. What they did, in essence, was train people. One group received empathy training. They were guided to feel and resonate with the suffering of others, to let the emotional reality of another person's pain land in their own bodies and awareness. Another group received compassion training. They were guided to practice something warmer and more active, a wish that the person suffering be free from that suffering, a cultivation of goodwill rather than a mirroring of pain. Then they put people in the scanner and showed them images and scenarios of human suffering, and they looked carefully and precisely at which circuits lit up under which condition. The results were published in 2013 in the journal Cerebral Cortex, and then followed with further work published in 2014 in Social Cognitive and Affective Neuroscience. What the scans showed was this: empathy training activated the anterior insular and the anterior midcingulate cortex. Those are the regions your brain uses when you, yourself, are in pain. They are the physical pain network, the circuit that encodes the felt quality of suffering as a bodily, visceral event. When you stub your toe, those regions fire. When you watch someone else stub their toe and feel a wince of sympathetic pain, those same regions fire. Empathy in the brain is not metaphorical pain sharing. It is the actual pain network, borrowed and applied. And what came with that activation when measured over time was increased negative affect. People felt worse. They reported more distress. The technical name for what developed was empathic distress, the state of being so immersed in another person's suffering that you cannot sustain the exposure. It is the phenomenon that hospice workers sometimes call compassion fatigue, though Singer would gently correct that name because what burns out in those workers is usually not compassion, but something closer to what the brain does under the empathy condition. The candle that goes out is not the compassion candle, It is the one that was trying to absorb every flame it encountered. The compassion training group showed something different, something quite different. The network that became active under compassion training was not the pain network. It included the medial orbitofrontal cortex, a region associated with reward and value. It included the ventral striatum and specifically a deep structure within it called the nucleus accumbens, which is part of what some researchers call the brain's reward circuitry, the circuitry that activates in moments of pleasure, of motivation, of approach. It included the ventral tegmental area where dopamine, the neurotransmitter of wanting and moving toward, originates. And it included the pregenual anterior cingulate cortex, a region implicated in positive affect and in what we might broadly call the warmth of social connection. This is not the pain network, this is its opposite. This is the approach network, the motivation to help network, the warmth and reward network. And people trained in compassion did not show increasing negative affect over time. They showed something closer to the opposite, a kind of warmth that was sustainable, that renewed rather than depleted. Singer herself has spoken about this distinction with care. The word she and her colleagues use for what empathy training produces in its less regulated form is empathic distress. And the word they contrast it with is compassion. Not as vague synonyms, which is how we usually use them in ordinary speech, but as distinct psychological and neurological states with distinct causes and distinct effects. Empathy in this framework means feeling with. It means resonating with the emotional reality of another person. And this resonance, this mirroring, has a cost, because the signal you are resonating with is pain, and pain is aversive, and prolonged exposure to aversive signal depletes you. The brain does not distinguish at the level of the anterior insular and mid-cingulate cortex between your pain and the pain you are witnessing. In a very real sense, it is your pain, and you can only carry so much of it before you need to put it down. Compassion means wishing well. It means warmth directed outward, a motivation to help, a wish for freedom from suffering. And this, in the brain, is not a pain response. It is a reward response. It is an approach response. It does not drain in the way empathy drains. If anything, it seems to do something closer to feeding the one who practices it. Not because suffering disappears from view. The compassionate person is not less aware of pain, not less honest about its reality, but because their response to that pain runs through a different circuit, one that orients toward relief rather than toward absorption. This is not what most people expect to hear. We have been taught in 100 different ways that feeling more is better, that emotional sensitivity is the mark of a good and caring person, that if you are not devastated by the suffering around you, you are not paying proper attention. And there is something true in that. A person who feels nothing in the face of suffering has a problem. The flat line is not the goal. But the finding from Singer and Klimecki suggests that feeling devastated is also not the goal, and that chronic devastation is not sustainable care. It is, in the end, a kind of withdrawal, because a burned-out caregiver stops caregiving, not because they don't care, but because the circuitry that was trying to carry the weight has given out. The nurses who leave the profession, the therapists who go numb, the people who stop reading the news because they cannot hold what they find there. This is not indifference. This is empathic distress. And the research suggests that training in compassion, real compassion, the wishing well variety, the one with warmth at its center, may offer a way through rather than a way out. Singer's larger framework for this work is called the Resource Project. It is a 9-month training study in which participants moved through different contemplative practices, including both empathy cultivation and compassion cultivation, and were tracked across a wide range of psychological and neurobiological measures. The Resource Project is one of the most ambitious scientific explorations of contemplative training yet conducted, and its findings, still being analyzed and published, add layers of texture to the basic empathy versus compassion dissociation. But the core signal from the earlier Klimek studies holds. The two circuits are real. The distinction matters. And knowing which one you are in is not merely philosophical. It is, in a measurable sense, the difference between a practice that sustains you and one that, without meaning to, slowly wears you down. Take a slow breath here. There is nothing you need to do with this information tonight. Nothing to solve or arrange. Just let it settle like a stone finding the bottom of still water. The stone does not strain to fall. It only lets go. The empathy versus compassion distinction was not invented by neuroscience. The Tibetan Buddhist contemplative tradition had been making a version of this distinction for centuries, in its own language, with its own careful cartography of mind. There is a Tibetan concept sometimes called nyingje, which we might translate as compassion, and it is described not as a merging with another's pain, but as a heartful wish, a clear and warm motivation that the suffering person find freedom. There is a recognition embedded in the practice itself that becoming overwhelmed by the suffering you witness is not the same as helping, that a doctor who collapses at the bedside is not useful, that the bridge has to hold its own weight in order to let others cross. The lab found this distinction by looking at brains in scanners. The tradition found it by looking at minds in practice over centuries of careful attention. They arrived at something recognizably similar from very different directions. And that convergence, two languages, two methods, the same underlying reality, is one of the quieter, more extraordinary things to sit with tonight. Now, there is another piece of this, and it runs underneath the empathy-compassion distinction in the way that foundations run underneath buildings. You do not see it, but everything rests on it. It is the question of what the training does to the body's stress response, not just the felt experience, not just the brain scan, but the actual biological cascade of stress hormones and immune signals that runs through the body when it perceives threat or difficulty. This is where the science becomes, if anything, even more specific. Cortisol is a word you may have encountered. It is the primary stress hormone produced by the body's HPA axis, the hypothalamic pituitary adrenal axis, which is a chain of signaling that runs from the brain down through the endocrine system and out into the blood. When the brain detects a threat, social, physical, psychological, real, or imagined, it triggers this chain. The hypothalamus signals the pituitary gland. The pituitary signals the adrenal glands which sit atop the kidneys. The adrenal glands release cortisol, and cortisol cascades through the body, preparing it for danger. Heart rate up, blood sugar up, immune function temporarily suppressed, attention narrowed, the whole organism on alert. This is a good system. In an actual emergency, it saves your life. The problem arises when it activates not in the presence of an actual tiger, but in the presence of a difficult conversation, a social humiliation, a day-long low-grade worry. The HPA axis, it turns out, does not strongly distinguish between a lion and a tense phone call. Threat is threat. And in modern life, the calls come frequently. One of the standard ways researchers study this response is the Trier social stress test. It is a reliably effective way to make people feel stressed in a laboratory setting. The participant is asked to give a spontaneous speech in front of evaluators and then to do mental arithmetic out loud while being watched. The evaluators are trained to remain neutral, not hostile, but not warm either, just impassive. This is enough. Most people find it genuinely uncomfortable. Cortisol rises. The HPA axis activates. You can measure it in the blood or the saliva. It is, in miniature, a measurable stress response in a controlled setting. The research team at Emory University, led by Thaddeus Pace, studied what happened to this response in people who had undergone CBCT, cognitively based compassion training. The program was developed at Emory partly from traditional Lojong training, the Tibetan practice of mind training, and adapted into a secular, structured curriculum. And what Pace and colleagues found in a study published in 2009 in the journal Psychoneuroendocrinology was that practice time correlated with reduced biological distress in response to the Trier social stress test. The more time participants had spent in the compassion practice, the lower their interleukin-6 response to the stressor. Interleukin-6 is a cytokine, a small signaling protein that is part of the immune system's inflammatory response. When the body is stressed, interleukin-6 goes up. Chronically elevated interleukin-6 is associated with a range of adverse health outcomes because chronic low-grade inflammation is implicated in everything from cardiovascular disease to depression. So when Pace and colleagues found that compassion practice time predicted lower interleukin-6 in response to a social stressor, they were not describing a subjective mood effect. They were describing a change in the body's inflammatory response, a biological, measurable, quantifiable reduction in the stress cascade. And the dose-response relationship, more practice, lower response, is important. It is not that participants who had done even a little CBCT showed dramatic effects. It is that those who had practiced most showed the clearest changes. The brain here is behaving like a muscle. The more you train, the stronger the adaptation. The more hours you put into the compassion practice, the more the body's reactive stress system, the one that was trying to prepare you for a threat that is no longer there, begins to recalibrate its thresholds. This is the biological stress cascade being blunted, not eliminated. The Trier social stress test still registers. The participants are not serene stones. They still feel the discomfort of being watched and evaluated. But the cascade that follows that discomfort, the downstream biological response, is measurably more contained in those who have practiced. Think of it this way: the alarm in your house still goes off, but the system has learned that most alarms are not emergencies, and so it takes a little longer to call the fire station, and when it does call, the signal is a little quieter. That is not indifference, that is discernment. That is the system learning the difference between real fire and burnt toast. This is the point where the popular framing of meditation as simple relaxation falls away most cleanly. Relaxation is passive. It is what the body does when the stressor is removed. You stop the stressor, the cortisol drops, the heart rate comes down, the HPA axis quiets. That is ordinary recovery. What the compassion training seems to do is something different. It changes the threshold at which the stressor registers as threatening in the first place. It changes the circuitry through which the response runs. The stressor is still there. The social situation is still uncomfortable, but the body's interpretation of it and its reaction to that interpretation have been altered by training. That is not sedation, that is skill. And it is worth noting very clearly that this is not a magic or an instant transformation. Pace's 2009 study was careful. The effects were dose-dependent, which means they showed up most clearly in those who had practiced most. They were correlated with practice time, not with simply signing up for the program. And the measures were preliminary, meaningful, replicated in spirit by other work, but not the final word. Science builds slowly, deliberately, through accumulation. What the Emory CBCT study adds to the picture is a specific biological mechanism, reduced inflammatory response to social stress, correlated with compassion practice. It is a real piece of the picture. It is not the whole picture. No single study ever is. There is another thread here that is worth following, because it connects the brain to the body in a way that is both precise and somewhat astonishing. The HPA axis, cortisol, interleukin-6. These are downstream effects. They are what happens in the body after the brain has made its assessment. But the question of how the compassion training changes the brain's assessment is partly an insular question. We touched on the insula in the last part. The anterior insula, the region that Sarah Lazar found to be thicker in long-term meditators, the region implicated in interoception, the brain's map of what the body is doing from the inside. The anterior insula is where you feel your heartbeat, your breathing, the quality of sensation in your chest and belly. It is where the body reports to the mind, and it is also, crucially, where the pain-sharing component of empathy lives, where the pain of another person registers as a somatic signal in your own body. This is why the compassion versus empathy distinction is partly an insular distinction. Under empathy training, the anterior insula is more strongly activated, more intensely engaged with the pain signal coming in from the outside world. The body is absorbing. Under compassion training, the network that activates is different. It includes the insula but is not dominated by it, and the dominant signal shifts from pain sharing to warmth and approach. But here is something subtle and important. The insula does not become less active in experienced meditators. If anything, it becomes more refined. The long-term meditators in Lazar's 2005 study had thicker right anterior insulas than controls, not thinner ones. They are not less sensitively tuned to the interior landscape. They are more so, which means the training is not producing numbness or disconnection. It is producing something like finer discrimination, the ability to feel clearly, to register accurately without being swept away. A skilled musician does not hear music less than an untrained person. They hear it more. They hear things an untrained listener misses. They notice subtleties of pitch and rhythm and timbre that are invisible to ears that haven't been trained to detect them. But a skilled musician also doesn't fall apart listening to a difficult piece of music. The sensitivity and the stability coexist. They reinforce each other rather than trading off against each other. Training in music, as in meditation, seems to produce this combination: greater sensitivity alongside greater equanimity. This is what Singer and Klimecki's work suggests about compassion training and the insula. The experienced compassion practitioner is not less aware of suffering. They are, if anything, more aware, more finely tuned to the interior signals that tell them what someone is going through, more capable of reading the emotional and bodily reality of another person with precision and care. But the circuitry through which that awareness flows has been trained into a different response. The awareness goes somewhere different. Instead of the pain network, it routes into the warmth network, the approach network, the motivation to help circuitry. The sensitivity is the same or greater. The response to the sensitivity has changed. This is, in contemplative terms, something like what the tradition calls equanimity. Not the flat grey equanimity of not caring, but the steady, luminous equanimity of a mind that can be fully present to difficult things without being destabilized by them. The Tibetan word is sometimes translated as stillness, but it is not the stillness of a stone. It is the stillness of a great bell that has just rung, settling, still resonating, still in contact with the sound, but no longer shaking. Rest here again, gently, just for a breath. The research we have been walking through from Singer and Klimecki, from PACE and the Emory CBCT team, from the earlier architecture of the Hölzel and Lazar structural findings, all of this has been tracing a single line. The line says, compassion is not empathy. Compassion is not relaxation. Compassion is a trainable skill that runs through different brain circuitry than empathy does, and the training of it changes both the brain's response to stress and the body's biological stress cascade. But there is a question that lives underneath all of this. And it is the most practical question, the one you might find yourself returning to in the quiet of tonight. It is the question of scale, the question of ordinary life. Because the monks in Davidson's 2004 study had between 10,000 and 50,000 hours of meditation. Most of us will not have 50,000 hours of anything, let alone a single contemplative practice. And the studies on structural change, Hölzel's hippocampal growth, Lazar's cortical thickness, these were done on experienced practitioners whose brains had been shaped by years or decades of sustained training. Is any of this available at a smaller scale? Is there something in it for a person who has 20 minutes in the morning or 10 minutes before sleep, rather than a lifetime in a monastery on a Himalayan hillside? The answer, as best as the research can currently tell, is yes. But it is important to be precise about what that yes means and what it does not mean. It does not mean that 10 minutes a night will produce the brainwave amplitudes that Antoine Lutz and Richard Davidson found in their monks. It will not. The gamma synchrony, that extraordinary high amplitude, phase-locked signal across distant brain regions that had never been recorded in a healthy human, that is decades of training. It is the Olympic performance. And ordinary people are not Olympic athletes after 10 minutes in a gym. But the question of whether Olympic-level performance exists is not the same as the question of whether exercise has any benefit. They are different questions. The existence of Olympians proves that the human body can do extraordinary things with sustained training. It does not mean that the only reason to exercise is to become an Olympian. You can go for a run in the morning and not be training for a marathon, and still heart rate, lung capacity, mood, cardiovascular health be genuinely changed by it. The same logic applies here, and the research supports it at the scale of ordinary human life. Barbara Fredrickson, a psychologist at the University of North Carolina, ran a study in 2008 published in the Journal of Personality and Social Psychology, in which she and her colleagues gave people 9 weeks of loving-kindness meditation, metta practice, the cultivation of goodwill beginning with oneself and extending outward. Not a decade of Tibetan monastic training, 9 weeks. A structured program practiced by ordinary people in the ordinary conditions of their lives. What she found was that the practice increased positive emotions, not in a dramatic or sudden way, but steadily, day by day, as the weeks accumulated. And these positive emotions, building one on another, began to compound into what Fredrickson calls personal resources. The participants developed greater mindfulness, a stronger sense of purpose, more robust social support, fewer illness symptoms, higher life satisfaction. The positive emotions were not just feelings that came and went, they were building something. This is the foundation of what Fredrickson calls the broaden and build theory. The idea, grounded in substantial evidence, is that positive emotions do not merely feel good. They broaden awareness, open the aperture of attention, expand the range of what a person notices and considers and is capable of. And through that broadening, they build lasting psychological and social resources. The effect is cumulative. A person who experiences more positive emotion over time is not simply happier in the moment. They are, gradually and measurably, developing a different kind of mind, a more flexible mind, a more resourced mind, a mind better equipped to handle difficulty when it comes. And 9 weeks of loving-kindness meditation moved these needles, not enormously, not all at once, but consistently and measurably. This is the human-scale finding that sits alongside the monk-scale gamma data. Different order of magnitude, same direction of effect. The practice does something at 9 weeks that is related to, though not identical with, what it does over 30 years. What happens after just a few minutes, an even smaller dose, is also worth holding. Sendri Hutchison, Emma Seppala, and James Gross published a study in 2013 that found something almost startling in its brevity and accessibility. They had people practice a brief loving-kindness meditation, just a few minutes, toward a stranger, a person they had seen but did not know. someone neutral without history or resonance. And what they found was that this short practice measurably increased feelings of social connection and positivity toward that previously neutral person. A few minutes? A stranger? A measurable change in how connected and warmly the participants felt towards someone they had only seen. This is not the same as 50,000 hours of Tibetan practice, but it is not nothing. It is evidence that the circuits involved in compassion and social connection are responsive at some level to even brief and simple cultivation. The soil is receptive. You do not need to be a master gardener to plant something. You need only to plant it. The structure of the metta practice itself, the loving kindness meditation that Hutchison and Seppala and Gross were working with, and that Fredrickson built her 9-week study around, is worth a moment of attention here because it is elegant in the way that ancient practices that have survived centuries of use tend to be elegant. Not because they were designed by committee, but because what worked survived. Metta is a Pali word. Pali is the language of the early Buddhist canonical texts, and metta means something like goodwill or loving kindness, a warm, open, benevolent orientation toward beings. Its companion practice is called karuna, which is compassion in a more specific sense. The active wish that suffering be eased, the motivation to help. Metta and karuna are related but distinct in the same way that joy and care are related but distinct. Metta is the ground. Karuna is its expression in the face of suffering. The traditional practice of metta moves in widening circles. You begin with yourself, not as a narcissistic turn, but because it is difficult to genuinely wish others well if you cannot first generate a real and honest wish for your own well-being. The logic is like oxygen masks on airplanes. You put on your own before helping anyone else, not because you matter more, but because you need to be able to breathe in order to be useful. You begin with yourself, with phrases like, "May I be well, may I be at peace, may I be free from suffering," not as demands or magical thinking, but as a gentle, genuine orientation of goodwill toward the being you are most intimately acquainted with. From there, the circle expands to a loved one, someone whose well-being you already care about, whose happiness you can easily wish for. The heart opens more readily here. Then to a neutral person, someone you neither like nor dislike, a stranger on a bus, a face you have seen but given no particular feeling to. This is the interesting edge, the place where the practice begins to ask something new. Extending genuine goodwill to someone neutral requires a subtle but real act of cultivation, reaching a little further than ordinary feeling reaches into something less conditional. Then, in the traditional form, to a difficult person, someone with whom there is friction, resentment, history, this is where the practice becomes challenging in a way that makes everything preceding it a preparation. And finally, outward to all beings, an open, boundless orientation of goodwill toward every living thing without condition or limit. What this structure does step by step is train the capacity for goodwill to become less and less contingent. Most of us feel warmth for people who are warm to us, for people we love, for people who are easy to love. The metta structure asks whether that warmth can extend beyond the warm and easy, whether it can reach the neutral and the difficult, whether it can become, over time, less a reaction to likable circumstances and more a stable orientation of the mind itself. The neuroscience, pieced together from Fredrickson's Broaden and Build work and from the Singer and Klimecki dissociation findings, suggests that training in this direction produces real changes in how positive emotion accumulates, in which brain circuits respond to the suffering of others, in how robustly the practitioner can sustain care without burning out. The traditional structure and the scientific findings are pointing toward the same underlying mechanism. Conditioning the approach circuitry, building the warmth and reward network, making the orientation toward others less a product of circumstance and more a product of training. And the word training is important. It is Davidson's word, the Olympic athlete framing the brain as muscle framing. And it is the right word, because training implies both effort and adaptation. Effort in the doing, adaptation as the result of the doing. You do not become an athlete by thinking about running. You do not develop the warmth circuits by reading about warmth. The practice is the thing, the sitting down, the turning the attention, the gently returning when the mind wanders, the doing of it again tomorrow, and the day after, and the week after that. The adaptation comes from the doing, and the adaptation, as Hölzel and Lazar showed, is structural. The brain that practices is physically different from the brain that reads about practicing. Different thickness, different density, different resting baselines. 8 weeks in the Hölzel study, a career in the monk studies. The timescale differs, but the direction is consistent. This is, in a sense, deeply ordinary news. We have always known that people become what they repeatedly do. Aristotle said something close to it. The Buddhist tradition built its entire training structure around it. The idea that virtue is not a gift, but a cultivation, that the mind is not a fixed thing, but a process, that what you do with your attention, day after day, shapes who you become. The neuroscience has added to this ancient intuition a new layer of precision. It can now name the circuits and measure the tissue and track the hormones. It can say, here, in this particular region of the prefrontal cortex, the grey matter is thicker. Here, in the amygdala, the threshold has shifted. Here, in the HPA axis response to social stress, the cascade is quieter. What was previously the territory of introspection and tradition has become, at least in part, the territory of measurement. And this is neither a triumph nor a reduction. It is simply that two very different instruments, the contemplative mind turned inward over many centuries, and the scientific method turned outward over a few decades, have begun to look at the same terrain from different angles and to find that their maps, while different in language and granularity, are describing something recognizably related. We will come back to that bridge, the formal structure of the relationship between these two traditions of inquiry, the institutions and conversations and collaborations that have made this mapping project possible. But before we do, there is one more piece of the biological picture worth staying with. It is a small finding, preliminary in scale, carefully flagged by the researchers themselves. But it is worth noting because it points in a direction that, if the signal holds and is replicated, would be quite significant. The finding involves telomeres. A telomere is the cap at the end of a chromosome, the protective tip, analogous to the plastic aglet at the end of a shoelace. Each time a cell divides, the telomere shortens slightly. Over a lifetime of cell division, the telomeres erode. When they erode to a critical point, the cell can no longer divide cleanly and enters a form of cellular senescence, a kind of biological retirement. Telomere length is, among other things, a marker of cellular age. Shorter telomeres are associated with earlier cellular aging. Elizabeth Blackburn won the Nobel Prize in Physiology or Medicine in 2009 for her work on telomeres and telomerase, the enzyme that rebuilds them. Elizabeth Hogue and colleagues published a pilot study in 2013 that found longer relative telomere length in experienced loving-kindness meditators compared to controls who did not meditate. The word pilot is important here. The sample size was small. The finding was preliminary. It does not establish that loving-kindness meditation extends cellular lifespan. It does not allow that conclusion. The study was the kind of early signal that earns the right to be investigated further, not the kind of result that settles a question. But it is worth holding lightly because it points toward a possibility that the contemplative tradition would not have framed in terms of telomeres, but might have framed in terms of vitality, of a certain quality of aliveness, of the way that a life oriented toward genuine care for others seems, in some traditions accounting, to be a life more fully lived. Whether the biology eventually supports this poetic intuition in precise, measurable terms remains to be seen. The signal is there. It is early, it is honest about its own limitations, and it is pointed in an interesting direction. This is how science works at its best, not in proclamations but in carefully accumulated signals, each one pointing, each one flagged with its own uncertainty, the whole picture assembling slowly over years and decades of work by many different people in many different labs asking many different but related questions. The picture that has been assembling in the years since Davidson and Lutz first put electrodes on the heads of Tibetan monks in a laboratory in Madison, Wisconsin, is a picture of the brain as genuinely plastic, not infinitely, not magically, but really and measurably plastic, in response to contemplative practice, and specifically in response to the practices of loving kindness and compassion. It is a picture of circuits being trained that have to do with warmth, with approach, with reward in the context of caring, rather than circuits of pain sharing or stress or withdrawal. The monks at the far end of this training spectrum show something extraordinary, something that had not been seen before in a healthy brain. But the direction of effect is not limited to them. It can be seen at appropriate scale in 9 weeks of practice, in 8 weeks of MBSR, in a few minutes of wishing a stranger well. The extraordinary and the ordinary are on the same spectrum, and the spectrum has a direction. That direction, from whatever you are now toward something a little more capable of care, a little better at sustaining warmth without burning out, a little more finely tuned in the insula, a little more settled in the amygdala, a little more responsive to the reward of genuine connection rather than the pain of absorbed suffering. That direction is available. It is not promised to anyone in a particular amount of time. It is not guaranteed in its effects. The science is honest about what it does not yet know, but it is available as a practice, a cultivation, a direction of training, and that tonight is worth resting with. Take a slow breath here, because what we are about to move into is the part of this story that belongs not just to the monks, not just to the laboratory, not just to the researchers who have spent careers peering at the soft tissue of contemplative experience through the cold lens of neuroimaging. This part belongs to you, and to the stranger you will walk past tomorrow morning without thinking about them again. Barbara Fredrickson is a psychologist at the University of North Carolina, and her question, when she arrived at this territory, was simpler than most of the questions we have been exploring tonight. Not, what happens in the brain of someone with 50,000 hours of practice, but what happens in the life of an ordinary person who practices loving kindness for 9 weeks. 9 weeks. The length of a university semester. The time it takes a garden to go from bare soil to something recognizable. A modest window. Her study, published in the Journal of Personality and Social Psychology in 2008, was a randomized trial. One group was assigned to learn and practice loving kindness meditation, the systematic cultivation of warmth and goodwill, beginning with oneself and radiating outward. The other group was assigned to a waiting list, and what Fredrickson measured week by week was something as simple and as difficult to pin down as positive emotion, not just reported happiness in a snapshot, daily positive emotions logged in real time across the arc of those 9 weeks. The practitioners experienced more of them, not dramatically more, not transcendently more, but measurably, reliably more. More love, more joy, more serenity, more amusement, more gratitude, more hope, more interest in the world around them. And then Fredrickson looked at what those positive emotions did over time. Here is where her theory, which she calls broaden and build, becomes relevant. The conventional picture of positive emotions is that they are rewards. You do something good, you feel good, and that feeling dissipates. A payoff, and then nothing. Fredrickson's argument, supported by the data from this study and others before it, is that positive emotions are not just rewards, they are investments. They broaden your awareness in the moment. You notice more, you think more flexibly, you connect dots you would otherwise have missed. And in so doing, they build resources. Real, durable, lasting resources, not just the good feeling itself, but what grows from it. And at the end of 9 weeks, the meditators had more of those resources than the waiting list group. They reported greater mindfulness, more sense of purpose in their days, stronger social support, fewer symptoms of physical illness, and more life satisfaction. The positive emotions had compounded slowly, the way a small amount of warmth compounds over a season into a thaw. This is not magic. It is not a claim that 9 weeks of loving kindness practice cures illness or fills a life with uninterrupted delight. The effect sizes are real but modest. What the data shows is a direction of movement, a modest, verifiable, human-scale version of the same direction the monks are moving at the extreme end of the training spectrum. Warmer, more resourced, more capable of sustaining care. And then there is the study that sits at the other end of the scale from Fredrickson's 9 weeks. Not shorter, but at such an accessible distance that it almost stops you mid-thought. Chadley, Stern Hutchison, Emma Seppeler, and James Gross, in a study published in 2013, asked a simple question: can a few minutes of loving-kindness meditation toward a complete stranger actually change how connected you feel to that person? The answer was yes. Participants in this study were asked to spend a few minutes practicing metta, the Pali word for loving-kindness, the deliberate cultivation of goodwill, directed toward a person they did not know. A photograph, a face. Someone with no relationship to them, no history, no shared context. And afterward, they reported greater feelings of social connection, greater warmth, greater positivity toward that previously neutral person compared to a control condition. A few minutes, not weeks, not thousands of hours, a few minutes of genuine well-wishing, and the social world became measurably a little less alien. There is something quietly astonishing in this, because it means that what the monks are doing at the scale of decades, training a kind of neural architecture of care over tens of thousands of hours, is not a different phenomenon from what an ordinary person can touch in a few minutes. It is the same phenomenon at different magnitudes. The direction is the same, the circuit is the same. The extraordinary and the ordinary are, as we said, on the same spectrum. Let us stay for a moment with the structure of the practice itself, because it illuminates why this would be so. Metta, loving kindness, is traditionally cultivated in widening circles. You begin with yourself, not with a loved one, not with an easier target, but with yourself, the person closest and often the most tangled. You settle the heart and you offer yourself the simple phrases: may you be well, may you be safe, may you be happy, may you be at ease. Not demanding these things, not forcing them, but genuinely wishing them the way you might wish them for a child sleeping in the next room. From there, the circle expands. A loved one, someone dear to you, someone whose well-being matters to you instinctively and without effort. You start there because the warmth is already present, and you are, in a sense, learning the feeling of warmth itself before you try to generate it in harder directions. Then a neutral person, someone you neither love nor dislike, a neighbor you have seen but not spoken to, the person who makes your coffee in the morning, a stranger whose face you half remember. The practice asks you to genuinely wish them well, which means genuinely attending to the fact of their inner life, their hopes, their difficulty, their ordinariness. And then the difficult person, the one toward whom warmth does not come easily. This is not sentimentality, this is deliberate training. The circuit being exercised here is the capacity for care in the presence of resistance, which is precisely the the circuit that matters most when the world gets hard. And finally, all beings. The widening continues past any individual toward something more like a field of goodwill, toward all creatures, all persons, in all directions, without limit. This is karuna, compassion, the wish that beings be free from suffering, which is related to metta but distinct in its orientation. Metta is the wish for happiness and well-being. Karuna is the wish for the release of pain. Different flavors of the same fundamental orientation of warmth. What the neuroscience shows across all the studies we have been exploring tonight is that this is not merely a mental exercise. Each time the circuit of warmth is exercised, it is, in a small way, strengthened. Each time the wish is genuinely generated, not forced, not performed, but sincerely felt toward a real or imagined other. The neural pathway that carries warmth is used, and used again, and again, until, in the monks at the far end of practice, it has been used so many times and so deliberately that it has become the default orientation. Not a state they visit, a trait they inhabit. Now let us talk about something smaller than warmth, but no less strange. Smaller in size than a fingertip. Microscopic. Present in every cell in your body. Telomeres. They are the protective caps at the ends of chromosomes. Picture the plastic tip at the end of a shoelace, the piece that keeps the lace from fraying. That is the rough analogy. Each time a cell divides, its chromosomes replicate, and each replication leaves the telomere a little shorter. Over time, short telomeres become a marker of cellular aging, of accumulated biological wear. Elizabeth Blackburn, whose work on telomeres and the enzyme telomerase earned the Nobel Prize in Physiology or Medicine in 2009, has spent decades establishing what it means for cells when these caps erode. Stress erodes them faster. Chronic psychological stress, the grinding kind, accelerates telomere shortening. And so it was a natural question to ask whether practices that alter the stress response, practices like loving-kindness meditation, might show up in telomere length. A pilot study by Elizabeth Hoge and colleagues, published in 2013, looked at experienced loving-kindness meditators and compared their telomere length to matched controls. The finding was that the meditators had relatively longer telomeres, longer, on average, than the non-meditators. Now, before you carry this too far, we have to be honest about what this finding is and is not. It is preliminary. The sample size was small enough that the word pilot is doing real work in that sentence. It is correlational, which means it cannot tell us whether the meditation caused the longer telomeres or whether people with a particular biology are both drawn to meditation and happen to have longer telomeres. These are not rhetorical objections. They are the real constraints that any careful reading of this science has to hold. And yet, the direction of the finding is consistent with everything else we have explored tonight. The biological machinery of stress, the HPA axis, cortisol, the inflammatory cascade, is altered by compassion practice. Stress biology is one of the mechanisms by which telomeres erode, and if the stress machinery is being quieted at the level of cortisol, at the level of interleukin-6, at the level of amygdala reactivity, then it is at least biologically coherent that the telomere picture might also shift. The finding is not proven, it is plausible, and it is worth watching. This is what careful science sounds like, not silence, not dismissal, and not breathless certainty either, just this is what we found, this is how much we trust it, and this is the thread we will keep pulling. Take a slow, easy breath. Notice, if you will, whatever has settled in your body since we began tonight. Not searching for anything, just noticing what is here. When you are ready, we will continue. Let us turn now toward something quieter than gamma waves and telomeres, toward a network in the brain that has no dramatic activation story, because its story is about going quiet, the default mode network. It is not a single structure, but a constellation of regions. The medial prefrontal cortex, which sits roughly behind your forehead toward the center, and the posterior cingulate cortex, which sits toward the back and center of the brain. These regions become active when you are not doing anything in particular. When you are resting, when your mind is wandering, when you are thinking about yourself, your past, your future, what someone said to you, what you should have said back. The default mode network is sometimes called the mind-wandering network, but a more precise name might be the self-referential network, because what it is mostly doing, in the background of your life, is generating the continuous narration of you, who you are, what you want, what you fear, what others think of you. The story that takes your various experiences and roles and memories and beliefs and weaves them into something that feels like a continuous, bounded, stable self. Judson Brewer and his colleagues at Yale, in a study published in PNAS in 2011, found that experienced meditators showed reduced activity in the default mode network compared to novices. Not zero activity, the network still functioned, but quieter, less dominant. The self-referential narrator was running, but at a lower volume. And more than that, the experienced meditators showed altered connectivity patterns within the network. The regions were talking to each other differently, a signature that is consistent with a different relationship to the content of self-referential thought. Not necessarily an absence of thought about the self, but a different quality of relationship to that thought, less identified with it, less caught in it. This is the neural correlate of something that sits at the very center of Buddhist teaching. The teaching of anatta, the Pali word, usually translated as not self or non-self, is among the most difficult and most easily misunderstood ideas in the tradition. It does not say that you do not exist. It does not say that experience does not happen or that nothing matters. What it points toward is the recognition that the fixed, bounded, continuous self that the default mode network is busily constructing is not quite what it presents itself as. That the feeling of being a single, stable, separate self is in part a story the brain tells itself. And that the suffering that comes from clinging to that story, defending it, enlarging it, worrying about it, is not inevitable. Meditators who have spent years loosening their relationship to that story show in the scanner a quieter version of the network that generates it. The brain, over time, seems to invest less in the narration. Now we should say clearly, the neuroscience does not prove the philosophical claim of anatta. The reduced default mode network activity is not a scan of enlightenment. These are correlates, not confirmations. The interpretation is contested, and careful scientists will not say that a quiet posterior cingulate cortex is the same thing as what a Tibetan teacher means by the recognition of non-self. The gap between a brain measurement and a philosophical insight about the nature of experience is real and large, but the convergence is not nothing. Two traditions, one thousands of years old, one barely decades into its best instruments, are pointing, with entirely different vocabularies and methods, at something in the same direction. A loosened grip on the continuous narrative of a fixed self. Quieter, at some level, than the ordinary mind, more available to the moment, less tangled in the constructed story of who the moment is happening to. That is worth holding gently without forcing it into more than it is. And now, the finale. The finding that sits at the edge of legend and laboratory in equal measure. For centuries, there have been accounts from Tibetan Buddhist practice of monks who could, through specific forms of inner visualization and controlled breathing, generate extraordinary body heat. In the deep cold of the Himalayas, in conditions that would be dangerous for an unprotected person, advanced practitioners of a practice called Tummo, or G Tummo in its full Tibetan spelling, were said to be able to maintain warmth to dry wet sheets draped on their bodies as a test to sit in conditions of extreme cold without suffering them. This is the kind of claim that tends to produce skepticism in a scientific mind, and reasonably so. The history of claimed extraordinary powers from contemplative practice, the Siddhis described in various traditions including levitation, telepathy, the ability to appear in multiple places simultaneously, is long and untested and, where tested, empty. But the body heat was different. Herbert Benson and his colleagues at Harvard Medical School traveled to remote monasteries in the early 1980s and documented, using thermometric measurements, that specific Tibetan monks practicing Ji-Tummo could raise the temperature of their fingers and toes by as much as several degrees. The study, published in 1982, was significant because it was careful, not performed under ideal laboratory conditions, but under the conditions of the actual practice, with actual monks measured by actual thermometers. And then, 3 decades later, the finding was replicated and extended. Maria Kojevnikov and colleagues, in a study published in PLOS I in 2013, measured core body temperature, not just peripheral, not just fingers and toes, but the internal temperature of the body in practitioners of Ji-Tummo. And they found that core body temperature could be raised by approximately 8 degrees Celsius during the practice. 8 degrees. That is a physiologically significant change, not a curiosity. A genuine and measurable alteration of a body system that medicine generally does not think of as voluntarily controllable. What is generating this? The practice involves a specific combination of visualization, imagining intense inner heat at particular locations in the body, and a controlled breathing technique called vase breathing, in which the breath is held in a particular way that creates pressure in the abdominal cavity. The thermogenic effect appears to arise from the combination of these two components. Neither alone, according to the Kojevnikov research, produces the full effect. Together they allow a meditator to intentionally activate what is essentially the body's own heat-generating machinery. Now let us be clear about what this is and what it is not. Ji-Tummo is not the same as levitation. It is not telepathy. It is not the full range of extraordinary claims made in various traditions about the powers that arise from advanced practice. The ones that have been tested and failed to pass that test remain legend. But Ji-Tummo is different. Because the body has actual thermogenic mechanisms, brown adipose tissue, the shivering response, metabolic heat production, and what the research suggests is that specific mental techniques can access those mechanisms voluntarily. The extraordinary in this case turns out to be an extraordinary use of something ordinary. The body can generate heat. The practice has found a way to consciously activate that capacity. This does not make the practice magical. It makes it more interesting than magic. And it brings us to Matthieu Ricard, who sat in the original 2004 study in Madison with electrodes on his head and generated gamma waves of an amplitude that had not been seen before in a healthy brain, and who was subsequently described by various news outlets as the happiest man in the world. He rejects this title, warmly, with some amusement, but firmly. He rejects it because what the data actually showed is more specific and more interesting than what the headline suggests. The electrodes measured left prefrontal cortical asymmetry, greater activation on the left side relative to the right, which has been correlated with positive affect in research by Richard Davidson and others. And he showed extreme results in that measure alongside the gamma synchrony. But left prefrontal asymmetry is a correlate of positive effect. It is not a direct measurement of happiness as a felt state. It is a neural signature associated with the approach disposition, with positive emotions, with the kind of orientation toward experience that tends to accompany well-being. To call someone the happiest man in the world based on this is a media simplification of a real finding. Ricard himself will tell you that what he experiences is not constant bliss. It is something more like a stable equanimity, a quality of groundedness and of not being thrown by circumstances that has been trained over decades of practice and that does not resemble the popular image of uninterrupted cheerfulness. This is important to say because the gap between what the science shows and what the headlines claim is part of what makes the actual science more trustworthy, not less. The researchers are not selling happiness. They are measuring specific neural signatures, specific structural changes, specific behavioral outcomes in controlled trials. And those findings are meaningful and real without being inflated into miracle claims. And on that note, let us say plainly, monks do not feel no pain. There was a study conducted by Antoine Lutz and colleagues in 2008 that looked specifically at pain processing in long-term meditators versus novices. What it found was not that the experts felt less pain in the sense of a numbed sensation. Their pain thresholds were not dramatically higher. What was different was the pattern of their response. The experts showed reduced anticipatory anxiety and the dread of pain before it arrives, which is often where much of the suffering lives, and they habituated to repeated painful stimuli faster. They recovered more quickly, they were not numbed, they were less caught. This is a meaningful distinction. The teaching is not that practice makes you incapable of pain. It is that practice changes your relationship to pain. The sensation arrives, it is felt, and it is not elaborated into a narrative of catastrophe, of permanent suffering, of identity. It is felt and released rather than felt and clutched. The Lutz 2008 finding gives that teaching a neural form, reduced anticipatory response, faster habituation, less rumination in the circuits that sustain suffering beyond its cause. Now let us step back and hold all of this together for a moment. In 1987, 3 people sat down with a shared conviction that something important could come from a serious, rigorous, mutually respectful conversation between contemplative tradition and modern science. Francisco Varela was a neuroscientist and philosopher, born in Chile, trained in Europe, working at the edge of consciousness science with an unusual willingness to take contemplative phenomenology seriously as a source of insight. Adam Engel was an entrepreneur and lawyer who had the organizational imagination to build an institution around an unlikely idea. And the third person at that table was the 14th Dalai Lama. From that conversation came the Mind and Life Institute, a home for ongoing dialogue between Buddhist teachers and scientists, neuroscientists, psychologists, physicists, biologists, committed to examining the claims and experiences of contemplative practice with the instruments and methods of modern research, not to prove Buddhism right and not to dismiss it, but to actually look. The Dalai Lama has said in various formulations over the years something that is worth repeating here. He has said that if science were to prove that a Buddhist claim is wrong, Buddhism should accept the correction. That scientific findings take precedence over scriptural authority when it comes to questions that science can actually test. This is not a small statement from the head of a religious tradition. It is an expression of a genuine epistemological openness, and it is, in its way, the spirit of the entire collaboration. Not faith resisting evidence and not science dismissing tradition, but 2 very different systems of inquiry agreeing to actually talk to each other about what they find. The findings that have come from that conversation over the decades since 1987 are real. They are also, in places, preliminary. They need replication. Some of them have been overstated in popular coverage. The field of contemplative neuroscience, still young, has the vulnerabilities of any young field: small samples, methodological debates, publication pressures, the difficulty of blinding a meditation study the way you can blind a drug trial. These are honest constraints, and the researchers working in this area are, for the most part, honest about them. Richard Davidson has said publicly that the popular media often runs much further ahead of the data than the scientists themselves would endorse, and yet the direction across the body of evidence is clear enough to take seriously. The brain changes in response to contemplative practice. It changes structurally in grey matter and cortical thickness. It changes functionally in the way regions activate and connect. It changes in its response to stress, in the behavior of the amygdala, in the levels of cortisol and interleukin-6 under conditions of acute psychological challenge. It changes in its orientation toward others, rooting away from pain-sharing circuits and toward reward and affiliation circuits when compassion, rather than mere empathy, is trained. And the changes are not only states, they become, with sustained practice, traits, baselines that persist even when the meditator is not meditating. As Davidson and colleagues showed in 2012, when they found altered amygdala response in subjects who were simply looking at emotional images, having been through compassion training, not sitting in any meditative state at all. This is the finding that matters most if we step back from all the individual studies and ask, what does this add up to? It adds up to this. The brain you have is not fixed. It is the record of what you have practiced. Every skill you have acquired, every habit of thought and response and attention that has become second nature is written there in altered synaptic weights, in thickened cortex, in pathways that have been used enough times to become default. This is neuroplasticity, and it is not a metaphor. It is the mechanism by which experience becomes structure. And if that is true for learning to play piano, for navigating the streets of London as a taxi driver, for any cognitive or emotional skill that gets practiced over time, then it is also true for the practice of warmth. Compassion is trainable, that is the central claim, and the evidence, qualified carefully, supports it. Not as a mystical event, not as a religious experience requiring belief in any particular framework, but as a form of mental training as real and as measurable in its effects as any other. The monks who sit at the extreme end of this training are, as Davidson said, like Olympic athletes. They represent what is possible at the far edge of disciplined human development in a particular domain. And like Olympic athletes, they tell us something about the direction and the distance, even if most of us will never cover that distance ourselves. Most of us will practice for 9 weeks or a few minutes before bed or in the car on the way to something difficult. And at that scale, the science says something too. The emotions compound. The social world opens a little. The amygdala quiets a little. The insula, the brain's map of the inner body, grows a little more sensitive, a little more capable of reading the emotional weather of the people around us. The default mode network, the one that runs the continuous story of the separate, defended self, gets a little quieter. Not silent, just quieter. And the direction of that movement is, on reflection, the same direction that the tradition has been pointing for 2,500 years, toward less reactivity, toward less suffering from the elaborations of thought around pain, toward more genuine warmth, not as a performance but as a trained capacity, toward a less defended sense of self, toward what Matthieu Ricard, who will not accept the title of the world's happiest person, would perhaps describe as a stable, spacious quality of being, less tossed by what the day brings, more able to meet it. The scanner can watch this now, the electrode can measure it, the randomized controlled trial can find it at 9 weeks, and the questionnaire filled out by an ordinary person after a few minutes of wishing a stranger well can record it at the smallest, most accessible scale. 2,500 years of practice and a few decades of neuroimaging have arrived from entirely different directions at an agreement. Care is a trainable skill. The brain that practices warmth becomes incrementally and measurably more capable of warmth. The circuit that is exercised grows, and the growing does not require a monastery. It does not require 10,000 hours. It does not require belief. It requires only the genuine and repeated act of wishing. sincerely, even if awkwardly, even if only for a moment, that the being in front of you or the one in your own chest be well. Let that be enough for tonight. There is a kind of symmetry when you look at it from a certain distance between what the laboratory has found and what the tradition has always said. Not a perfect symmetry, not a proof, but a family resemblance between two very different ways of paying attention to the same thing. The tradition said the mind can be trained. Suffering is not a fixed condition. The capacity for care is real and developable. The scientist looks, measures, publishes, replicates or fails to replicate, and gradually builds a picture that says the brain can change, the stress response can be altered, the circuits of warmth are distinct from the circuits of pain, and practicing warmth builds something in the brain that is stable enough to show up on a Tuesday, not sitting in meditation, just living an ordinary life. The monks sat in a room in Madison, Wisconsin, with electrodes on their heads, and they generated something the researchers had never seen before. Not calm, high activation, high synchrony. A brain working in the way an Olympic athlete's body works, with efficiency and power born from extraordinary training, directed towards something the scanner can see but not fully name. And somewhere, much closer to where you are right now, an ordinary person sits for a few minutes and wishes a stranger well. The stranger is unknown to them. The moment is small, and the data says that something moves. Tonight, that is where we have arrived, not at a revolution in human understanding, not at proof of anything the tradition has claimed about the furthest reaches of contemplative development, but at a picture of direction, of a genuine, measured, biologically real movement from wherever you begin towards something more capable of care. And of the science, still young and still learning, watching that movement with growing clarity, the brain that is most open, most capable of genuine warmth, most settled in the amygdala and most alive in the anterior insula, and most quiet in the network of self-narration, that brain was trained, not given, not inherited in a fixed form, trained. The way everything durable and real about a human being is built, through practice, through return, through doing the thing again when it does not feel like it is working, through the widening circle of the wish. May you be well, may you be safe, may you be happy, may you be at ease. These are old words. They have been used for 2,500 years in one tradition or another. And now there is a set of machines in various laboratories across the world that can see in the living brain of a person who has practiced these words long enough and deeply enough exactly the traces of what they have built. The science does not explain the tradition away. The tradition does not excuse the science from rigor. What they share at this particular meeting point is a genuine curiosity about the same question. What does care do to the mind that practices it? What happens over time to the brain that returns again and again to warmth? The answer tonight is this. It grows. Rest with that now. Let the details settle wherever they land or drift wherever they will. You do not need to remember any of it to have been touched by the direction of it. We have traveled together in this long night from an electrode-covered head in a laboratory in Wisconsin, generating brain waves no healthy human had ever produced, all the way back here to the oldest, simplest instruction, wish well. And the arc between those 2 points is not as long as it seems. They are part of the same story. Sleep well. Subject closed for the night. Let it all relax away.